Hello girls, so this video is about the modulus function, which is also known as the absolute value function. And we've talked about that. So the absolute value function x, which is indicated by having two vertical lines on either side, you effectively can read it as just by saying make x positive. So if x is already positive, then the absolute value function doesn't do anything. If x is negative, it just makes it positive, right? So for example, the modulus of 7 is 7, while the modulus of minus 5 is 5. Okay? What it actually does, and part of the reason we call it the modulus function, modulus is a fancy way of saying size. The modulus function is basically a way of measuring the distance of something from the origin. So the modulus of minus 5 is that distance there, 5. The modulus of 7 is that distance there, 7. Okay? That is what the modulus function does. And we can define the modulus function to be two things. So this is called a piecewise definition, a piecemeal, or whatever you want to call it. But it equals x when x is greater than or equal to 0, and it equals negative x when x is less than 0, which is exactly what I've done here. Right? And moreover, we can draw that. So if I've got a little number line here, and if you think about what this function, modulus of x, looks like, right? For x positive, it is just the line x, so it's that, the line there with slope 1. For x negative, it is the line negative x, which is that line there, the line with slope minus 1. Okay? That is the sketch of y equals absolute value of x. So it's continuous, but it's got a point, right? So I don't have to lift my pen from the paper, but it's got a point there. And so it doesn't satisfy some other things that we'll talk about later on in the year. Another way of defining it is to say that, and I think this is how I might have introduced it one day in class, if I remember rightly, that the modulus of x equals the square root of x squared, right? Remembering that square root is defined to mean positive square root only. So if you think about, the square root of negative 5 squared, for example, then that is the square root of 25, and that is 5. But, it's going to get rid of that for now. So, some examples, if you've got the absolute value, the absolute value of 7 plus a, and you know that a is, minus 2 or something, and this is the absolute value of 7 minus 2, so it's the absolute value of 5, and so it's 5. If you've got the absolute value of a times b, where a is 7, instead of picking on 7 and 5 a lot, so you know what, I'm going to pick 4. Then that's the absolute value of 7 times minus 4. So that's the absolute value of, what's that, minus 28. So that's 28, right? There's no trickery here. As far as the number work goes, it's pretty easy. If we want to sketch some functions, so let's say my function is, the absolute value of x minus 2, for instance, and I wanted to sketch that. So if I draw the line y equals x minus 2, it looks like this. 2, and basically I just want to make that positive everywhere. So here it's already positive, so I leave it as it is. Down there it's negative, and I'll just make it positive. Okay. Another way of thinking about it is, come on pen, the absolute value of x function shift. I'm not sure where that paused. Shifted to the right 2 units is what I was trying to say. Right. So similarly, if I asked you to sketch the absolute value of x plus 4, then that would look something like this. That's 4, and that's 4. If I asked you to sketch the absolute value of 2x minus 3, so that's the absolute value of 2 brackets x minus 3 over 2. So now the lines have slope 2, and it's shifted to the right 3 over 2. So something like this. point there's 3 over 2, and that point there is 3. Okay, and the two line segments have slope 2 and minus 2. Okay. If I wanted to do something, whoops. Oh god. If I wanted to do something slightly more complicated. So something like this. Right. If I wanted to sketch that, then I might think about what happens when x is negative. Well, when x is negative, we know from the definition back here that the absolute value of x is minus x. So this is x minus x. So that's 2x. And then for x greater than 0, we know that the absolute value of x is just x. So this is fx equals x minus x. And that's 0. And so we can sketch that. That looks something like this. Alright, well that goes through the origin, and that line there has slope 2. Another option might be to sketch this one. Oops. Yeah. And I might actually borrow the space that I have up here. Just get rid of stuff for now. So when x is negative, this is going to be x times minus x. So that's minus x squared. And when x is positive, it's just going to be x times x. So it's just going to be x squared. So, whoa, that's a nice horizontal line. There we go. So the graph looks something like this. Right? Half a parabola, half a parabola. Almost like a cubic, but the curves are actually parabolas. Out of interest, if I drew a cubic on top, what do you think it would look like? It would look something like this. And I'll leave you to think about why. And maybe we'll talk about that tomorrow. 7.5 minutes. I think I might leave it there. Because that's a nice break in the textbook as well. That might be a good place to leave it. And then tomorrow you can finish off any of this, and also hopefully by the end of tomorrow you will be on top of, and everyone will be in the same position in terms of not spending time catching up on work. Have a good Wednesday. It's actually Wednesday today.